Okay, back for a tutorial number 4. Let me just get it started. So a few things. I have a cold, so I sound a bit different to previous videos, and also the window decorations have changed. It's because I mucked up my Linux distribution. But hey, that's life. Anyway, so it's not by choice. I prefer it to look like Windows 2000. Anyway, let's load up the previous work. So all the fun stuff is in here. So to start, we'll just quickly go over what we learned. So we have variables. Variables have a type. So there's a floating point variable. That's a real value. So 0.1, 4.3, anything like that. Integer is a number like 545, 546, 9, -2, 0, that kind of thing. Strings are bits of text. Strings go within the two little quote marks. And flag blocks, everything between the curly brackets happens when you click on the flag. This is assigning a new value to a variable. This is a while loop. So while this bit here is true, the computer will do the stuff on the inside over and over and over again. This is calling a function called random int between 1 and 6 and putting that back into value. This is increasing total by value, by the amount that's stored in value. So if value was 3, total would increase by 3 because we evaluate this section first and then we put it back into total. I was looking at this. Why did I write it like this? I can't remember why I wrote it like this, but the obvious way to write this is that way. So if I hadn't mentioned this in the previous video, and I may have just been half asleep. So comparison, to see if two things are the same, we use a double equals like you would in Java or C. But if you want to say it's not equals, you can do if it's not count equals to 9, or we can say count is not equals. So there's the not. So the exclamation mark is the not symbol, but you can also put it with the not equals. So if count not equals to 9, there you go. So now we know a couple of loops. So the 3 loops that we've gone through, in fact, these are the main loops that are currently in Glitter. There's one other one, but I'm not going to pay attention to it today. We've got forever. So that just does everything over and over and over and over and over again. And any other framework other than a Scratch-like framework, this would be a terrible piece of code. There's another way of writing it though. You can write the same thing by using a while loop. So we've got the while loop. We could just say while true. That is functionally identical to a forever loop. And it may in fact be the case that internally this is converted into a forever loop when it is compiled. Compiled is the act of turning the code into something that the computer understands better and can work with better. And the last loop was the repeat, and that just takes a count, so you can repeat 10 times. You could repeat a, one last little thing. I could go, if there was a variable called a equals 3, for example, we could repeat that, and then we could say a equals a plus 1. So just one little thing about this is that you might think this loop goes on forever because you come into here and it says repeat 3 times. But when you go into here, you change a to be a plus 1. So a now becomes 3 plus 1, which is 4. So you'll be repeating the loop 4 times. So the next time you come through, it's going to keep getting bigger. Well, it doesn't do that. It just reads the value the first time you come here. So this reads it as 3 at this point. And after you've changed this, a will then be 6. A equals 6 afterwards. That's not proper code. But that would be what a equals, because it would have come through here and gone through this 3 times and increased it by 1 each time. 3 times 1 is 3 plus 3 is 6. Just a reminder, double backslashes or forward slashes, who knows, our comment, that's a single line comment, and the double multi-line comment, if we haven't done that already, is, we don't need any of this code, is this is a multi-line comment. Thanks for watching. Don't forget to like, share, and subscribe. All right, so that's the multi-line comment. It has a slash and an asterisk and to start with, and then it has a asterisk and a slash to end it. So anything between these two little things is not read by the computer. That's another comment. I'm going to leave that right there just in case you wish to like, share, and subscribe. Sorry, I'm going to have to cough a bit. All right, now the main thing I wanted to get onto today. So we've done some important things. We've done variables, loops, and conditional statements with ifs and else. These are kind of the important building blocks of most programming languages, but there's another sort of one, which is the idea of functions, or they're called a variety of things. Sometimes they're called procedures, and sometimes they're called functions, and sometimes they're called methods, and sometimes they're called blocks. That's what Scratch calls them, so we're going to call them a block. We're going to go back to doing some funky graphic stuff now. So I'm just going to get rid of everything. It's all going. But before I do that, I'm going to go for all right, so I don't overwrite the previous one. So long time ago we had a thing where we used the pen down command, and then we would move like 100 spaces. We're going to do this. We're going to use a repeat loop. Repeat 10, repeat 4. Turn left 90 and do that. And so when we ran that, we got a square, because we might make this a little bit more interesting. Hold on, we'll do turn left 10, move 10, and we'll do that 36 times, and then we'll actually see what it was doing. So it drew a circle. I'm gonna hide. So hide's another command. Hide makes the sprite disappear, but we just want to look at the at what it draws. So we're drawing this lovely looking circle that's just made up of 36 lines. If we zoom in, you might see that they are made up of, no, you can't. Oh, yes, you can, kind of. That's one line, and that's another line. So it's not a proper full circle. But let's just say this is an example. We want to repeat some code, but we're going to use this somewhere else in our program code. But we don't want to have to keep typing out the same kind of stuff. So this is where blocks come in. Blocks are basically how you can create a new command. So this is a command that's built into the computer. It's a built-in function or a command, whichever way you want to call it. And when you type it out like that, you tell the computer to do that particular function. So the hide function makes the sprite invisible, and you might be able to guess that the show function makes it visible. So those are all built-in functions. What we want to do, I want to just check that I'm actually recording. What we want to do is we want to make our own little function and put some code into it. So we'll start off and do a simple one, and this is how you write it out. So circle. And so we put our code in here. So a block. So in Scratch, and the basic functions that are currently in Glitter are defined as blocks, and that follows the terminology from Scratch. So you have the keyword block followed by the name of the function and two little brackets, which we will come back to in a little bit. And then we have the code that goes here. And now when we go down to here, we can type we now have a new command. Our new command is circle, and then if we go and run it, we have exactly the same thing we had before. But now we could do something kind of a bit wacky. We could go repeat 10. Maybe we shouldn't like do 10. Let's just do 4. And then we're going to turn left 90 degrees. And we'll see what happens. So it's going to draw 1 circle, 2 circles, 3 circles, and 4 circles. So we get a nice little picture that we have drawn, and we used our handy little circle command. So you might want to change it so that you can specify how big the circle is. So maybe we'll add in a parameter. I should use the word float, shouldn't I? But a double is what I would use. Double and float mean the same thing as a real valued number, just because that's the way computers work. Just to remind people, floating point numbers, there's just the way it refers to how numbers are stored internally in the computer, and a double just means it's a double size floating point number, which means it's more accurate. But in Scratch and Glitter, there's no distinction. They're all just high precision. They're all basically double, so you can write whichever way you want. But we'll take size, and then we can move size. So we can use this. This is a parameter variable. The only thing that is different between that and a normal variable is that you cannot currently, or at least I don't think you can. You can't reassign the value. You can't in Scratch anyhow, so it might compile. Cannot be reassigned values. All right, there we go. There were 2 errors there. Oh, the other error is down here, because now this takes a parameter. So now we have to give it a thing. So what we will do is we will go int circle size equals 3 equals 5, and then we will go circle size 5, and instead of turning left, we are going to go circle size plus equals 5. All right, and we'll see what happens. So we run this, and we'll tell me there's some errors. Cannot be assigned values. Why? Oh, that's right. So one of the bugs I have to fix is, I think I mentioned this last time, that will work fine next time, but this time you have to do it like this. Circle cannot be found within scope. Okay, what is going on? Repeat circle. The variable circle cannot be. The variable circle. Ah. Okay, there we go. The variable circle cannot be found. That's right. There's no variable called circle. It's called circle size. So now we will run it, and you'll see it draws 1. And that did not work, because I did not pass in that is a variable. Alright, so the first time it will call circle with circle size, and then it will adjust circle size by 5, and you should be able to guess that it draws it like that. So it's not a very good, you can see that it hits the top of the screen because it's using the move commands. So I will be adding options to turn off fencing in the next version, as well as fixing quite a few little bugs that I have discovered recently. But anyway, you can see that we'll move our little sprite down there. But before we run it again to double check that it works, and we're gonna increase it by 1, and then we're gonna do it like 10 times. And we're going to start it, and you can see it's going to do this. And you're like, well, this is taking forever. This is a computer. It's supposed to do things fast. Because this is built on the sort of the model, the programming model or the environment model that Scratch uses, these things sort of, like when you do a repeat loop, it doesn't do it as fast as the computer can do. It does it so that if you've changed the screen in some way, so over here we've moved and we've changed the screen, it will wait a bit before it does the next bit. So if you're doing this 36 times, it's going to take 36 screen updates basically before it finishes this, because you've done stuff like it's kind of complicated to explain, and I'm not going to do it here, but this is the slow way, and it's designed so that you can make pretty pictures and move things backwards and forwards and all that kind of stuff. If you want to go fast, you have to make this block into a turbo block. So Glitter currently is slightly different to the way that Scratch does stuff. Scratch has a command, when you have a block in Scratch, it's called run without screen update. And this does not quite do the same thing. This still updates the screen. It just runs everything really fast. So if I do that, so the way to turn this into a fast block, there are two ways. The way that I normally do it is I put an asterisk after the word block. But because some other languages use an asterisk like this for functions for a different meaning, I have now added and probably encouraged the exclamation mark. So a block with an exclamation mark is a turbo block. So it will not go through and wait for the next screen update. It will do all of this as fast as it can. This loop here will still wait every screen update, so it won't go too fast, but you should see, well, okay, it was faster than I thought. I thought it would actually. Interesting. Oh, actually, I know why, because yeah, that makes sense. Okay, so if you want it to actually, you can go sleep. Sleep is the name of the command that I should use. I keep using, I have the command is wait time, and you can wait 0 seconds. The other way of doing that is to type the word yield. But this word here, I think the other way is seed, as in I'm seeding things, but none of these words make sense to me. Well, feel right. I want to use the word yield, but I can't use the word yield because other programming languages use the word yield for something else. But we'll just use wait time. And we're going to wait 0, but this actually causes it to skip to the next frame. So you'll get that nice effect where it comes up like that. You can, of course, do other things. You can go move 0, and you'll get the same effect. So this triggers this loop. So this is making it way more complicated than it should be. If you're getting into programming, don't worry about this. But if you do something in a loop that involves, or the screen is updated at some point, either by this sprite or some other part of your code, this loop will only happen, will pause until the next frame update. But if you don't do anything, and you only call turbo things or call functions that don't or do things that don't update the screen, it will go very fast. But if you do this, even though you're not actually moving, it counts this as updating the screen. So you get the nice effect. So that's kind of basically all there is. So we can make a nice little we can make some more functions. We can do make it a fast one, box, and then we'll say actually what we will do is we'll call it shape, and sides number of side count, side length. I'll just call it length. Alright, so we will go repeat side count. Alright, and then we will move length, and then we will turn left 360 degrees divided by side count. All right, so now we can be kind of a bit fancier. So instead of going circle, this is probably not going to work. We'll find out. We'll go shape, and we'll have a four-sided shape, and we'll just do it by 2 because I want it to be kind of large. And then we'll run it. Not what I was hoping for. Times 10. And so you can kind of see that it works. So we've made some squares. What we will do is not that one. We'll move them over to the side for this trick. So we do end up back where we started. So I wonder if we can get to see. Oh, we can't. Yeah, so this thing will get us back to where we start. So if you move like up, turn, move, turn, move, turn, move, and then we turn one more time, we end up back where we started and facing the direction that we were started. So we can do other shapes. Now we can do 5. Didn't quite fit in the box, but still. And 6. And so on. You kind of have to bring those down. So that makes a sort of nice little feature, I think. But what can we do that's kind of interesting? Well, what we can do is we can clear the screen each time. I think it's clear. We'll find out. And as you can see, when we clear, you don't actually get you don't see everything. You just see it growing out like that. So what we could do is, instead of changing the circle size, we could just do 6, and we'll do 10. What does that look like? It looks very tiny. So we'll do 70, 80. All right. And what we're going to do is we're going to add in a turn left of 10 degrees. And it's quite funny because it's hitting the corners. And we want it to keep going though. So to make it keep going forever, we shall use a forever loop. Forever. So that creates a forever loop. And now we've got one shape going there. What we could do though is we're going to turn left. Doesn't really matter because we're turning left 180 degrees. And then we're doing the same thing again, and then we're going to turn left 180 degrees. And then we're going to get back to where we were. And as you shall see, we don't need to move 0 anymore because we've changed our sprite outside of the turbo thing. You've got this. Now you've got like a nice little neat pattern. If you really, really, really want to see something cool, you can do that. But what you could do, and this is where it's going to get a little wild, you could say block spin inside count int length. So we're going to take this code and we're going to do that. We're going to take the whole thing actually. We're going to So use Shift and Tab to highlight a block of code, and Shift and Tab if you want to indent it. So Tab increases the indentation and Shift Tab reduces it. And then we're going to have steps. So we'll repeat steps. And we're going to try and do a whole circle. So we're going to 360 divided by steps. Alright, and so we're just going to comment that out for a second. And then we're going to come down here. So we've got a thing which is a spin, and that works kind of the same. So we will spin, except I made a boo-boo. I want to actually make quite a few boo-boos here. Side count and length. So these are actually, oh my gosh. So a few little things that we need to discuss when working with functions like this. These are the same names as the variables that I've used up here. Will it get confused? No, it will not get confused. So when you write the word side count within the shaped block, it knows you're talking about this side count. So the fact that you have a side count here and you're passing it as a thing, they do not have to be the same name. This could be side count x, and that would have to be side count x. You can't have side count because this function, this block, does not know what side count is. Side count only exists within here. What exists here is side count x. There is also the chance that maybe you have a variable called length equals 20. When you use length, it's going to use the length that is the closest to it in a way, the one that's within the block that you've defined. If you want to talk about this length, you can use this word. So you go this dot length, and then it will be talking about this length here. But if you don't do that, it will go for the closest length, or the one that's most in scope for it is probably a slightly better term, which is this length here. So in general, if you're confused, don't make variable names the same all over the show. have different. I would probably just put an underscore for the outside variables and not an underscore, and then it doesn't get confusing. But everybody has their way of doing things. So these 180s, these are kind of like they have their fixed values because I'm flipping the sprite around. So let's see what we get. It tells me I have an error. Incomplete parse on token. So we'll have to do some error testing here. So it says syntax error in line 49. And so you can look at this and say, well, what is going on here? And it's a bit confusing. So this is always going to be the most confusing. I'm going to try and add code to make this error message less confusing. But it's saying this, it doesn't understand what this this curly bracket is. And if you look at this, it matches up with there. But what's going wrong is that I haven't finished writing out this. So the error is actually this bit here. And the reason it's complaining about this is it's trying to read this in. So it started going off and it's getting as far as it can by reading this in as a function name, and then it's about to try and read the parameters, and then it ends up with a curly bracket, and it's like, well, that doesn't make any sense. So it's telling you the error is here because this is the next token that it couldn't understand. So, and the reason it couldn't understand it is nothing to do with that thing, that little symbol, the curly bracket. It's to do with the spin not being completed. So we will do a side count of 5, a length of 100, and say step of 36. No, that's not right. We'll do a step of 4. All right. And then when we run it, it should make a shape that looks kind of like that, which is, so we've moved around. So there's 4 different steps. So we did 5. You'll see it will make that kind of pattern, which is quite pretty. But let's say you wanted it animated. Well, now we can do that. So now we can go forever. And this is where it differs from Scratch, because I think you're still going to have, but we're going to add in a function, turn left 10. Actually, we'll make it real smooth. Turn left 1. And then when we run it, so we're going to do that forever, you get that feature, which does not quite go the way you want. But all you have to do is add in your friend Claire, and voila, it is a pretty pattern that is rotating around, making everybody feel happy inside. And you can, of course, change this. It's having a few problems with that one because it's bouncing off the top of the screen. So if we make it slightly smaller, that will work. We'll have to break it down to 50, and we'll go up to 10, and we'll see what we get. So we start to get some nice little graphics. We could do, this is circle, side count. We'll go int side count. Last thing equals 5. So we're going to add in some of the stuff that we did from last time. So this is the side count. And then we're going to add in a new block. Or maybe we won't. Okay, I'm going to finish it there because I actually have to go to the supermarket real fast. But yeah, we're gonna slightly add a few extra things. Next time we're going to go on to arrays, and then we've basically got the gist of coding, the basics of the coding that you need to know, and then we'll go into more complicated things afterwards. But anyway, thanks for watching. So the important thing today is how to make blocks, and then you can call those, make new commands, and then you can call those commands from within other commands, and you can call them multiple times, and they make making pretty pictures a lot easier than you might think. So thanks for watching, and bye.